Okay, so let's get to the Runge method. So this is just directly from Bing. It says that it's an numerical method used for the approximation of solutions to ordinary differential equations. It's an iterative method that involves function evaluations at several points within the step interval and incorporates a weighted average of these evaluations for the final solution. Right. So okay, there are links to these ones. It says that the method produces four different slopes, right, and uses them as weighted averages, as opposed to the Euler's method, which computes just one slope at a time. Okay, so let's just get here and then work more to what the Runge method is. So now the whole idea of solving the Runge method is just like let's say you're using um, the Euler method or other methods, right? And then you have higher powers of x. So let's say you have x squared. Um, let's say the function is having like higher powers, right? Um, the Ranjikata is a more effective way of solving it when it has higher powers than Taylor series or other methods, right? So that's why it's a preferable method. So with Ranjikata, you just have to do just three things by iteration, right? So you just have to find your k1, your k2, and then you have to find your yi plus 1. So that's all. So now what you normally do is that just like the other one, so you find you have your xi, your yi, right? Then use them to find your k1, k2, and this, and then you end up having your xi plus 1 and your yi plus 1, right, in that order. So that's just how you solve this, right? So let me just take you here, right? So let's do this. So with the Ranjikata method, we have second and fourth order. So we'll do the second order first, and then we'll do the fourth order. Now these are the formulas you have to know. So a k1 is just a function of whatever they give you, right? H times the function of those things, and then your k2 is a function of the increment of those things, right? So if you see here, right, this is how the increment is working. So you have your xi, right, plus h. So you're just increasing the x component. Now over here, you're not just increasing the y component, you're increasing it by the k1. So you take k1 times h plus the yi. Alright, we'll explain this one into further details, right? And then you have your yi plus 1 equals yi plus h on 2, multiplying your k1 plus k2, right? Now let's say you have this equation. Now let's tailor this equation to look something like this, or maybe a more appropriate since we don't have a y here. So that means that we'll have our xi plus 1, right, to be xi plus h on 2 k1 plus k2, right? Right. Now our k1 will be equal to h times x of t, right? And then our k2 will simply be h times our x of the increment of t, right? So just say t plus h, right? Yeah, so obviously these things would increase, right? There will be incremental values, right, with the x2, but then just get this idea, right? So this one is an increment. So that means that if you are going to get the main x will simply so if I'm to bring an x here, so this would be this, and then this one will be x plus k1 times our h, right? So that's as cool as that. Okay, so let's solve this example. Okay, so first of all, we said that k1 is our h. So in the question they will give you h, right? So over here, let me just write the conditions down. So they wrote x of 1 equals -4, which simply means that our t naught equals 1 and then x naught equals -4. Cool. And then we have our h equals 0.01, and then right, and then they even added an alpha. It's not necessary though, but then alpha equals 1. This alpha is the same as the t naught. Okay, so now let's start. So we find our k1 to be the h times the x of t. Now what's x of t?
h times, so let's just write this down. Our h times the function, which is 1 plus x squared plus t cubed. Good. So now over here, now what x and what t are we dealing with? We're dealing with x naught and t naught, right? So you have your x naught, t naught. So you have 0.01 multiplying 1 plus our x naught. Our x naught is somewhere here, which is negative 4 plus, so negative 4 squared plus 0.01 squared, right? When I type this into your calculator, you end up getting 0.18, right? Okay, so you have this, right? The thing is, okay, so let me just clarify something. So you see, you have your x is negative 4, okay? So you might just be tempted to do this. So, sorry. So if you do something like this, right, you end up getting a whole different value. So for your own safety, once you have negatives, just try and put them in a bracket this way, right? So this will save you a lot of time, right? So that you don't work with wrong values. So now we've done our k1. Now we need our k2, and our k2 is h times x of t, but incremental, right? So let's say t plus h, and then our x plus the k1 times h, sorry. Anyway, so this incrementals. So our k2 will be equal to the same function again. It's not anything different. So we have our same function, that's 1 plus. Now x naught here becomes x1, right? So x1 squared plus t1 cubed, right? So now here, our x1 is equal to the, so our x1 will be the incremental, right? That will be the k1 times the h, right? So our x1 will be x naught plus k1h. So this should be x naught was 1, right? So x naught was 1. Sorry, x naught was minus 4 plus k was 0.18 times our h, which is 0.01. So this gives us minus 4 plus 0.0018. Okay, yeah. So and then you can just enter this 0.01. I'm doing some small acrobatics. So you have minus 4. Okay, so your new x1 will be negative 3 points, so negative 3.9982. Right, so this is your new x1. Now your t1, right, your t1 will be your t naught plus h. Our t naught was 1 plus 0.01, which is as 1.01, right? So basically we are done with this. So now to find your, that means we are now set to find our k2. So to find our k2, you can just say k2 equals our minus 4, sorry, k2 equals 0.01, right? 0.01, that's our h, times the function, our function 1 plus x1. Our x1 was negative 3.9982 all squared, right? Plus our t, which is 1.01 all cubed. Just enter that. Okay, so this is what we have. Okay, so you have your 0.01 plus 1 times, don't forget to put your negatives in brackets, and then this cube, right? So you just enter, you have your our k2 to be equal to 0.180159. Okay, yeah, so this would be our k2. Now what is next? You find your x1, right? Or better to say your xi plus 1, right? So that will give you, so your overall x1 Now, let me show you something here. Now this question, right? It's just like this one we found here, right? This one was to find your K2, right? So I don't know if I should give it a different name, but then this is fine, right? But then just know the difference, right? After finding your K1 and K2, you are supposed to find your overall x1, so your xi plus 1, right? Then that will be your um, so from the formula we wrote earlier, right? So over here, I'm trying to locate it. Okay, so over here, right? So you have your xi plus 1 equals your xi plus h on 2 multiplying k1 plus k2, right? So they just that, right? So now your xi, so we are going to do for x1. So your original x1 will be x1 plus, so that be x0 plus h on 2 k1 plus k2, right? So this will be minus 4 plus 0.01 on 2, and then you have your sum, right, which is 0.18 plus 0.180159. So this one, when you punch into the calculator, and I'm getting negative 0.0381992, right? Yes, so this is the value for your x1, right? Now the next step is that you use this one. So use this one to find, so you now need your original t1 and then x1, right, to find your next one. So you have your k1 to be equal to h times x of, let's say, t1 x1, right? And then k2 be h times x of say t1 plus h comma x1 plus k h, k1h, right? And then your x2 will be your x1 plus h on 2 multiplying the sum of your k values, right? So this is just it. So let's so that means you have to do the same thing all over, right? Okay, so let's get to that. Sorry, let me try entering that. It seems I'm seeing some. Yeah, so we have negative 4 plus 0.01 onto multiplying 0.18 plus 0.180159. Okay, so I think that was probably an error in entering the figure, right? So okay, so this one is rather the so I think the this ones were misplaced. Okay, so this one is actually negative 3 points, so it's actually negative 3.9981992, right? So that's just it. Okay, so you use this one to find your next one. So you say your k1 equals your function of that. We've done that already. So you say 0.01, which is your h. Then we multiply by the function, which is 1 plus x1 squared plus t1 cube. Okay, now then you enter your values. So 0.01 into bracket 1 plus our x1, which is this value, negative 3.9981992, right? And this one plus, so it's a squared actually, plus 1.01 cube. Sorry for the mistakes. Yeah, so you have your k1, right? Then when you input that, you can have something like 0.1668, right? Yeah, so because these are long decimals, you might always you most likely find some errors, so just go through and see if you find errors, just correct them, right? And then your k2, right? Then your k2 will be h, multiplying your 1 plus your x1. So that will be your, so this will be a new value, right? So like I said earlier, so this one will be a new value. So that will be your x1 plus your k1h, right? And then this one will be just a normal sum. So that will be x1 plus 0.1668. I'm really hoping the values in the slides are correct. I'm just trying to make the video shorter. Times the h, right, which is 0.01, and then squared, and then you add your t1. So a t1 plus h, so t1 plus 0.01 or q, right? And then you do this calculation. So if you do this calculation, then you end up with your 0.1546, right? So with this, then you use your k1 and k2 to find your x2. So our x2 will be x1 plus h12 k1 plus k2. So our x1 was we had our x1 from the previous step, right, which was this value, right? And then we have so negative 0.9981992 plus h12, so our 0.01 and 2 multiplying our 0.1668 plus 0.1546. Now here I'm seeing some discrepancy in the slide, right? I'm seeing that their x1, right, is a little different from what I have. So I'm trying to figure out why is that way. Because over here we had it this is just the answer, right? This is what we are using. Let me see. 30 point. Okay. Yeah, so that was the initial value, right? So this one was actually wrong because that was not the value. It was 3.81992, right? I think I made a mistake to here, so sorry for that. Yeah, so this value is actually wrong. When you type this into the calculator, you won't get this value. And then so that will be your k1, and you have your case here, right? So let me just confirm from my calculator. Okay, yeah, so that's it. So when you solve and also get a new one, you can probably like, let's say you solve and get new values, you can just put your new value in the comment section so that maybe other people who watch will see that there was an error, right? But then apparently I'm not seeing anything. I'm sure probably there was a mistake with the slide. Yeah, so you have this, right? Then you have your x2 value, right? Then that would be like now your 3.81992, something like this, right? Yeah, so I'm sorry, it's 253, 253, right? So that's your 3.8253. Yeah, so that's just all for it. And then one thing you should take note is a possible OBJ question is that the local error for the second order, right, is it's a function of the h cube, right? So that means that the local error is just a function of h cube, because yeah, and then the global error is a function of h squared, right? So these are possible OBJ questions they can ask. Now there is a fourth order Runge Kutta, right? There's a fourth order Runge Kutta method, and then okay, trying to get okay. So with the fourth order, right, something like this. Okay, so with the fourth order, you have to find 4k values. So here you have your, so second order you find 2k's, fourth order you find 4k's, right? It's really a lengthy process. So this will be your normal k1, and then here the k2, you see that there are a little, some small variations. So here take h12 and you take half of this, right? So with the first order Runge kata, you don't take half, you just take the values, right? But then here you're taking half of those values and you're adding them. And then for your k3, you do the same thing again, right? Your k4, basically you do the same thing, just that you keep using the new. So at your last step, right, your last step, which is the k4, you don't take half, right? So if they give you something like this, and then so this will be your final answer for the new value, right? So that would be y1 plus I, so yi plus 1 equals yi plus this and all of that. This is really lengthy, right? I hope it doesn't bring it to the obj because it can take a lot of time. Now your local error, right? So here, so your local error will be a function of the fifth power of the error, right? And your global error will be a fourth power of the function of the increment, that's the h, right? Yeah. So something like this. So let's just go through. So something like this. So assume he gives you 1 plus y plus x squared, right? And then he asks you to use the Runge kata fourth order, right? With two initial conditions, y of 0.2 and y of 0. So you can just take this one as your, and then they give you y of 0 equals this. So this is your x0, x1, x2, right? Then okay, so this one is just trying to give you what the parameters are. So over here with your k1, right? So k1, you have your f of x0, your y0. So this is just the normal function you have, right? So you put your y0, which was your so if you come to the y0, your y0 was 0.5 and your x0 was 0. So you, okay, so you put that in here, right? So you have that over here, right? And then your k2, you do the same thing like we've been doing, right? For the, like just like the one we did for the first one. So you have your x1 plus that, right? So your x1 now, so the x1 you'll be using will be that, right? So this is your k1, and you put your k1 here, here, sorry, and then multiply by your h, and then your x, there's not really x1, that's the x you have first, right? So that'll be your x0, then use that too, yeah. So till you get to k4, and then you put everything inside and you find your y2, depending on the question, right? It can be an x or, yeah. So here's a y, so yeah, so you have your y2, then you do the same thing and find your, so over here just sometimes it might just be helpful to know some of these tables, right? Because it's obj, right? So here you have your, so this is what he gave us, right? And then the value for 0.2 was this and that. So what we are trying to basically do, we are trying to define points, right? So you define your x1, x0, y0, x1, y1, x2, y2, and with these points you can, so let's say you had more of these points, you can accurately describe the curve, right? So that's what Runge kata is in. So it's just like a way of solving the, you are solving the ordinary differential equation by finding the correspondent values at each point of the curve, right? Should I say each point of the slopes? Okay. Yeah, so basically this is everything for Runge kata. Yeah, so I recommend you probably solve some of these examples, just the ones in the slide. Probably those are the ones that will come. Okay, thank you.